So I kind of dropped off on my philosophy meetups, and they're usually pretty good, but I don't know. So why don't I just fire ahead with my presentation that I have been thinking about this a lot, and I'm gonna bring up some issues. Some of you guys may completely disagree with that, with what I'm going to talk about, which is perfectly fine because I'm not going to suggest or claim or defend any specific point of view here. I want to get some things out for discussion, um, and we'll kind of see where it goes. So hopefully this presentation will you know conjure up some ideas and get us thinking. That's what these meetups are supposed to do pretty much. So here, can everybody see my screen, by the way? Am I sharing it okay? I see it. Okay. So there's the title page. Now, here I define AGI in, pretty much as simply as I can. I really like this, excuse me, this definition by Mario Bunge, who's a philosopher. A general predicate or statement is one that holds in more than one case. So, when I think of AGI, I'm thinking it's got to work in more than one case. So, pretty much this gets me started and oriented, because really the problem with AGI is that can it work in a multiplicity of cases, in cases we haven't seen before, and that might take on all the shades of variety that Jim just illustrated for us. And so, yeah, you can read through my definition of the basic problem. Basically, this is a generalization machine, okay? And we look out in reality and we see a lot of individual things. So if we're gonna look for a model for generalization, it's pretty much gonna come from up here. So that's the challenge. I mean, I tried to reduce it to the external world has objects and we've got ideas and we've got generalization. So there's my basic problem. And so we're going to take a look at some of the extremes here to try to orient ourselves. And what I've got as a starting point is what I call, I guess, maybe grandiosely, the pole of no generality. So if you've got suppose you just you've got a client that comes to you, write a program, but the client only has the input's always the same. So you write your program and it always does exactly the same thing. It only handles one case. Client says, well, we got to change the program. Okay. Well, I've got another case you got to handle. So in that case, we've got to write a new program. So you're obliged to write a new program every time. And my last bullet here, this seems silly. Obviously, I guess it seems kind of silly to think in this extreme, but when you stop and think about it, I mean, every kind of automation has to have some kind of generality built into it. So like even a calculator, I mean, nobody would call a calculator AI, but I mean, it's going to handle more than one case. So this is a continuum we're talking about. And here we have the situation where it only does one thing, so you just have the output. Pretty simple, I realize, but so that's just the extreme no generality pole. And then here I've tried to envision, okay, what if you had an AGI that what I term to be absolutely general? So any input, so you've got this great program, great AGI, you've written it. It can read any input you want, any format you want. You got numbers, you got images, you've got customer data, you've got video, in any order, whatever it is, we'll take it, and we'll figure out what the case is, and we'll perform any function at all. That you can tell it to me in advance, or you can tell the program in advance, or you can describe it as it's executing. Whatever output you want, we got it. We're going to do everything. So I added this point number 4. suppose the rules of reality themselves change during the execution of the program. It could happen. I mean, you don't have any guarantee when you, this is a, you know, if you're a pure empiricist philosopher, you start to think about what you can actually count on. And it could be that tomorrow the rules of physics change. So here in this absolute polarity, virtually anything can take place. So we go from absolutely can only handle one case to can do absolutely anything. So I guess I just like to orient myself around the extremes and then try to find it gives me a kind of an orientation. So the result of my, you know, brilliant analysis here is that generality is indispensable. So for any kind of computation whatsoever. And as you guys know, in the old days, we coded up symbolic rules, and now it's mostly neural networks. And the kind of the problem that's emerged over time is that it might work within the domain, within the confines of a narrow AI domain, but will it generalize? Does it have general principles and rules? And so we can't achieve absolute generality anytime soon. We all know that, but so we can push the boundaries. So anyway, this is just the basic starting point. We've got either no generality, complete generality, and where we're at right now. So I thought about this, and I thought about it for a while, and there's kind of the tension between two approaches, and again, I'm not saying that this is just kind of what I think, and you guys could interject your comments or whatever at any point, but my point here basically is that so if you take what I call an AGI-A, and it kind of works by applying any function whatsoever that appears to produce a generality. So basically, as long as it works, that's good enough. And I think I'm thinking of, you know, a recent example might be GPT. So I mean, which is a pretty impressive structure, but you know, when you're looking at it, so it takes sentences and then it kind of extrapolates what has happened and what will happen, but you're kind of left with this feeling that it's got a function, but is it a trick, or what are they actually basing it on? And so there's a lot of arguments out there and a lot of criticism, but it works, right? It does a lot. It does some impressive stuff, but so kind of labeling AGI-A as just we've got this function and it does appear to work, but then kind of infiltrating the ways the ways people think about AGI is that designers seem to prefer some kind of invariant generality, and you see this coming up in a lot of different ways. Well, they're saying we're not just going to take any trick or any method that happens to work and it looks like it's achieving generality. We want to base the results, the generality, on something which we think of in advance, that we can see that the theory contains some kind of invariant generality, which is always going to be true, and which we're always going to use that on every case. So, and in thinking over these things, I mean, for a situation like that, well, I'll come to it in a minute, but I just want to, does anybody buy into this idea that there's kind of a tension out there between some kind of approach which gives you results, but you're not really convinced it's anything beyond just a kind of a contrivance?
Yeah, that there aren't specifics that we're able to think about specifics. But when I think about a specific, it's because I'm drawing in lots of related generalizations.
Welcome to Amal Kelker. I just saw his face. Okay, well, I guess I'll move on, guys, and so we got. Sorry, I'm going through it. Anyway, okay, so I was just trying to highlight the difference between kind of an AGI approach that might value creating functions that will result in generality, but it might come across like as a trick. And then secondly, another type of AGI, which I termed AGI-B, which could be something that would apply some kind of invariant generality, which we often hear as first principle. So what's the advantage of a first principle in your design? Well, I mean, here's the seductive part, is because if you're sitting there thinking, well, what am I going to rely on? Well, I want something that's absolutely general. I mean, how can you miss? It seems like if you hit on something that's absolutely general, and remember, when we're trying to create programs that are absolutely general, so if you can find a principle that, like, killer first principle that's absolutely general, it seems like that would be the key. So that seems pretty obvious. And just as a definition, I like to think of a first principle. You don't need to derive it from something else as like a deduction. You don't need to consider it really. Well, you might need to consider it in connection with other things, but it's something so obvious that you can think, okay, that's going to apply to everything. And so, from these two bullets here, that's kind of been my orientation for a while in AGI, that I've always kind of tried to look for those things in reality, which you could say you can really count on them to work in all cases, and especially if it's pretty clear what the principle is. So then down here I just say, how do you know what the first principle is? How do you know what to use? Are they adequate? And this is, of course, the big challenge. So the next slide. Here I list some examples of first principles that I didn't really think about this really carefully, but I just kind of came up with some off the top. You hear a lot of talk about causality lately, and causality is a great example of a first principle from 500 BC, when Aristotle, and he had his robe and everything. He's walking around Athens talking. What are the first causes of things? What are formal causes? What are final causes? What are efficient causes? And so you hear a lot about causality now, and it's something we all can identify with without a lot of explanation. We all know what a cause is, but is it in your AGI theory somewhere? Is it in GPT? Well, I don't think so. I don't see any evidence that it's in there. If it isn't, then would it help to put it in there? Like a horse has 4 legs, like Lance was saying, but what's the cause of, I don't know, what's a good causality that has something to do with, what's the cause of the horse being elevated in the air? Well, it's caused by the 4 legs. But I don't think, would GPT might be able to answer that, but anyway, that's just an example. And I came up with some other things that, you can see that different designers hold different things to be really evident and invariant and so general that they are using that as the base of their system, that these principles are so globally useful, what we're going to apply them to every instance. Back in the early days of AI with Newell and Simon, and I remember reading a book about I think it was Newell, might have been Simon. Anyway, they could do everything with rules that in their estimation, that rules and symbols would work for everything. That was the place to start. And Psych, I know some of you guys are familiar with this, where they set out to encode almost every conceivable rule of reality. And that's another example. Neural networks, we tend to rely on nodes and weights. That's the kind of the first principle for neural networks. So which brings me to the discussion questions. And this is the last slide. And pretty much self-explanatory what the questions are.